Yes, I'm going to record to that. All right, so it looks like it's going to work. Okay, thank you, gentlemen, for joining me. I know we have about two other folks that are going to be logging on here, but I just wanted to kind of set the agenda so y'all know kind of how it's going to run, and then we'll just kind of go from there. So, like I said, in about 2 minutes, we'll start the actual presentation where Adiz and Chris will be talking about the Commvault story and how scale out is the new scale up. We have a use case that we'd like to present to you. And then we're gonna leave about 15 minutes for questions and answers. So if y'all throughout the presentation have something that really interests you or resonated with what's going on in your environment, just write that down and we'll get that answered, and we'll get that going for you. So we actually have people from all over the US with us today. So from Florida all the way to Hawaii and all the way as north as, I don't know, whoever's the northest person. So you know, this is really just a big, broad group. We also have folks who come from, you know, an executive level over to the hands-on guys that are really working with, you know, the hardware and the software. And so this is really supposed to be a presentation that's giving you that, the bigger picture, as well as we can get into the weeds. And Chris Stubson is the go-to guy. He's got the Superman logo for that. He's the go-to guy for the in-depth stuff. And Adiz is by far my favorite when he talks about our story. Okay, so I'm gonna turn off my camera. I'm gonna be off, but if you need anything, chat me. And if your lunch did not work, or if it did work, I'm glad. If it did not work, we can help you make sure that you get your $25 gift card for the time that you're spending with us, all right? Yay. I'm gonna mute everybody except for Adiz, and Adiz, I'll just hand it over to you from right now.
Thank you, Naomi. So hopefully everyone can hear me okay. Let's kick it off here. Yeah, actually, it's amazing. This is now my first anniversary here at Commvault. I remember the days, in the early days, actually, when I joined Hedvig. I mean, we were about 30 people building the team, trying to gain that initial visibility momentum. That has been quite successful. I mean, we signed up some big names. We signed up some small to mid-size customers as well. Like, I mean, big names included defense contractors like Airbus, British Airways, Volkswagen, Scania, and ranging all the way to school districts and academic institutions. But scale out versus scale up has been really one of the interesting topics. And I will zoom in a minute. But at the end, the goal is basically establishing that fluid, easy to manage, easy to operate infrastructure. And when I say fluid, that fluidity is kind of also driven by the fact, hey, if that infrastructure is spanning from the data center, maybe across multiple data centers, shifting to cloud, and in a seamless fashion, bringing a single presentation layer to foreground, which is easy to manage, easy to operate. But with that said, I mean, Commvault acquired Hedvig about a year ago now. October 1st is the anniversary date, and several drivers. I want to zoom into that and give you an idea, and then we can expand how it can support your vision, how it can apply in your domain, and dive deeper, basically. So with that said, I mean, quickly from an agenda perspective, I will share at least the high-level trends and some high-level visibility into what is the portfolio building blocks of Commvault and how Hedvig fits. And then Chris will jump in, open up the kimono, get into further detail, sharing a customer example. So with that said, if you look at the big part of the challenge, I mean, if you look at specifically the modern data estates, I mean, it's turning into a wild west. That's the reality. I mean, hybrid cloud, multi-cloud, emerging applications, DevOps, containers. As if that wasn't enough, most recently also COVID. I mean, everything is basically impacting the organization's ability to manage the data. And the data, of course, in different silos over the past couple of decades, blocks and files and objects and the primary, secondary. Next to that, of course, globalization and changing regulations are increasing the pressure on everyone. So if you look at the primary challenge, it's all around mass data fragmentation. Because if you look at the silos, those silos and the fragmentations impacting the ability, specifically organizational ability for resilience, for security, compliance, cost, or how you can be more efficient. And on top of that, you see every day, every month, every year, changing demands, requirements for data transparency and traceability. So in that domain, if you look at basically what Commvault is envisioning in regards to how we can support your vision, how we can help you to overcome these challenges, an intelligent data management solution is basically the foundation to everything we do. And what I mean by that is basically, in its core, the ability to store the data, the ability to protect the data, optimize how it's stored, how it's accessed, and enabling the use of that data. And the intelligence, of course, needless to say, is the secret sauce, right? It's not about just ones and zeros. It's all about understanding the data and matching it to the required environment. And if you look at the portfolio, basically, whether it's Hedvig or Complete or Activate, these are basically all making up the critical building blocks of that journey. In fact, if I were to open up, I mean, today, when you look at that streamlined portfolio where that unified user experience is basically on top of many other things, on one side, I mean, you have the complete backup and recovery portfolio, which includes basically all the key building blocks, whether it's the backup and restore or DR technology. Then you have basically the activate, orchestrate capabilities, which is aiming you to identify how you can optimize files are stored, what is stored, who owns. So basically kind of supporting all that compliance, all that traceability. And next to that, Metallic and Hedvig complementing that portfolio. And the goal is more than anything else, I mean, catering to different consumption flavors in that domain as well. Well, some of you may be interested in solving these challenges with software deploying in your data center. Some of you may be interested in leveraging the appliance wherever it makes sense. And some of you may have interest in a SaaS type of deliverable like Metallic. But the flexibility is, of course, the foundation to many things we do here. And when I say also flexibility, next to that, it's important to highlight what are some of those underlying drivers, especially in this intelligent data management race. So, of course, on top of everything, cloud first is basically driving all of our development strategy. I mean, how we prioritize the roadmap, and how we introduce the product. And that doesn't necessarily mean just running everything in the cloud, but also introducing that infinite scalability. Hey, very easy, add nodes, add capacity in a seamless fashion, expand the capacity, expand the power of the underlying platform, whether that platform is basically residing in the data center or in the cloud. But next to that, maybe a hybrid or maybe a multi-cloud vision is basically driving what you like to do or how you like to deploy everything over time. And of course, a unified experience is also key. And what we aim there is definitely more than anything else, introducing the simplification. How you manage and operate this environment, how you provision, how you drive policies, how you initiate workflows. So the goal is increasing the operational efficiencies while giving you the power to manage and operate everything from a single point, wherever that may be, whether it's basically at home, managing that infrastructure, or maybe from the data center. But the tooling and the capabilities are aiming to simplify that journey. So in this environment, where do we fit? Right? If you look at it, when I say Hedvig, of course, we are coming from a storage infrastructure pedigree. So if you noticed, storing and protecting the data was one of the key ingredients in that domain. So what we bring to the table is, at a very high level, a software-defined storage solution. And the core idea with that software-defined storage solution is taking advantage of commoditization. And what I mean by that, with the traditional storage where scale up, adding basically building the refrigerator, adding more capacity onto an existing node was basically the key driver, which necessitated also planning for 5 years, 7 years. The idea here is shifting. And in fact, the founder of company, of Hedvig, coming from Amazon and Facebook, and innovating there with Dynamo and Cassandra. Those are all of his brainchilds. He basically aimed to introduce the underpinnings of such scale-out capabilities, the resilience to corporate world. So with that said, Hedvig. Well, Hedvig, that software-defined distributed storage solution, well, you can deploy on those off-the-shelf servers. You can deploy in the cloud. And upon such deployment, the outcome is basically a distributed storage solution. The core idea, you can expand, you can start with the 3 nodes, 3 x86 servers, maybe all flash, maybe all spinning disk. It's all driven by the throughput performance expectations, right? But from there, you can add node at a time, 3, 5, 10, or 300, 500, thousands. But highly predictable scale-out solution, you can basically expand as demand necessitates. So what we did here also, resilience built in, right? A distributed architecture, whether it's basically protection with replication or erasure coding. So the data is protected always against a disk failure, node failure, maybe site failure as well, all that comes with the solution. And finally, when it comes to simplification, that simple management layer, that single entry point to the environment, but more importantly, I touched the point earlier, mass data fragmentation, to reduce and eliminate mass data fragmentation over time. I mean, we support from the same environment, block, file, object. We support from the same environment, variety of flavors of technology stacks, maybe virtualization. It could be VMware, it could be Hyper-V, it could be KVM. Containers, it's a very hot topic, and the way we deliver storage is definitely mimicking how containers basically innovate and deliver modern capabilities to support microservices in that new program. Well, I shouldn't say only programming, but in the new compute domain, compute paradigm. And next to that, backup, of course, with Commvault, whether it's basically supporting with Commvault or other backup solutions. The core idea, catering to a variety of workloads from the same solution, catering to your needs. Well, you may say, hey, by the way, we have reference architectures for everything, right? Variety of server providers. But the goal is more than anything else. Well, if you choose to leverage Hedvig in an appliance mode, HyperscaleX. If you choose to leverage your provided, your preferred server technology, that's no problem as well. I mean, hey, just like any other software, we have some minimum requirements, right, to be able to run efficiently, take advantage of the underlying compute environment. And not only that, on-premise, well, you may want to span into the cloud, take advantage of the cloud. You may want to have a hybrid strategy, or even a multi-cloud strategy. But regardless, the way we solve the challenge, hey, it's a software layer, right? You're able to run that software layer, provided underlying resources, provided network is there to service this domain. So if you look at one end of the spectrum with Commvault, focused on data protection, on this end, you see nodes, those servers, typically with higher density, 144 terabyte going all the way to 336, giving you basically highly attractive TCO as well, next to simplification, next to reliability, next to resilience and performance. The other end, well, looking at primary use cases, it eliminates over time that mass data fragmentation. So, well, when you start with data protection, eventually it gives you the ability to expand towards primary space, maybe containers, maybe Kubernetes, maybe VMware. But the core idea, well, for example, CSI, directly supported, introducing capabilities to move data between clusters, all coming, all available through the platform. So with that said, I'll pass the flag to Chris at this point. So he will share with you a bit more in-depth perspective into the technology, into the solution.
Very good. All right, let me share my screen out here and just let me know when you can see it.
It works.
No objections yet. Very good. All right. So good morning and afternoon, everyone out there. My name is Chris Dubston. I am one of the engineers here with our emerging technologies, focusing especially around our Hedvig technology, which powers Hyperscale. So I'm gonna run through a little bit of how all of those bits and pieces you just heard about. How does this work? How do they plug together? And what does it look like? And I got a quick use case that we can kind of go through with one of our customers that has deployed, who has scaled out with Hedvig, just to kind of give you an idea of what kind of scale that they're looking at. So first and foremost, just to kind of set the table for what we're going to be talking about, I'm going to define a little bit of the Hedvig technology that we use. So first and foremost, what you're seeing right here is just an example of a 3 data center configuration. I actually I have simulated one of these in my lab. Well, hopefully we get to a demo today. And across here, just keep in mind that Hedvig deploys as an active cluster. So every node in a cluster participates in the cluster. And that's kind of the key with scale out, so that every single node that you add increases performance. It's a linear scale, and there's no diminishing returns. Adie's mentioned before that we have production certainly in the 1,000+ node range. We've even scale tested well out past 4,000 nodes in cloud providers. So this is kind of one of those alien technologies that you always get to hear about that can kind of scale out as far as it needs to go, and be as fast as it needs to be depending on what requirements are. So again, 3 nodes to begin with. These can be in one stack. These can be spread across multiple locations, and then you can scale 1 node at a time. Hedvig is a 2-tier architecture. So this first tier is the storage tier that makes up all of our storage nodes. These are the x86 frames that Adie was mentioning before. These can be physical frames. These can be cloud instances. It does not matter. As long as it's an x86 frame, we can use that as a storage node. The second tier up here at the top is the Hedvig storage proxy. This is the essentially, if you think of legacy storage as an original steel frame that has controllers in the top of the box attached to the back plane with spinning disks attached to that plane, all wrapped in steel. That's what kind of the legacy construct of storage is. This is a decoupling of that concept. So these storage proxies are now those controllers. They're virtualized. They are pushed out as close to the data source as possible. And this gives it a lot of power in this architecture because you can now scale that connectivity and that performance out of band with the storage requirements. You don't have to add a node just to make more resilient connections out to a hypervisor or a container. And these proxies can be virtual components deployed within those containers or hypervisors, or they can be bare metal. In the case of something like Commvault, where we're deploying with the backup software, those storage proxies are actually deployed inside of a media agent, giving it that superpower to be able to address all storage nodes simultaneously. All those proxies are the brokers of the protocol. They handle encryption as close to the data as possible. They do dedupe block elimination across writes to give you more efficient network connectivity. And they can even handle read caching so that you can increase performance all the way out to that edge layer. So this is, when wrapped all together, this is the definition of a scale-out storage structure. So, the only other part that I want to make sure that is kind of clear in what we're going to be seeing, because you'll actually see a screen of this in a few moments, is that when we define how we provision storage out to an application, we create what's called a virtual disk. And this virtual disk is just a set of definitions. It can be of any size, it can be of any protocol, and it can also be of any replication or erasure coding method. So all of this is handled on a virtual disk by virtual disk basis. You don't have to pre-group servers and give them defined RAID sets or any other pre-planning mechanism that makes these clusters kind of stovepiped into purpose. You can actually define even the replication policy at the point of creating the virtual disk. So I can say I want a 1 terabyte disk that's going to be used for backup. I want it erasure coding so it's nice, space efficient, spread across multiple data centers. And I wanted to make sure that when I define that data center awareness, that every block that I write is resilient to all of the other data centers, so it can endure a loss of a complete site. And all of that is done with a click. Right? That is all a checkbox just saying that I want this to define, because it intelligently interrogates the DNS location of where the other nodes are. There's no pre-configuration and no pre-grouping of the server nodes or the server disks. It's all done on the fly. And it's very impressive. The encryption, deduplication, and compression is available on a virtual disk by virtual disk basis. In the terms of Commvault, you'll see me in a minute when we build those volumes. I actually turn those off for backup volumes because that intelligence is built down into the software layer. But there are plenty of things where that is not there, or it's advantageous to use that for containerization or some of the things for additional space efficiencies. So you can define those on a disk by disk basis, and you can also define how many snapshots and clones. So snapshots and clones are kind of table stakes for most provisioning and most storage. But the interesting part with how we handle snapshots and clones is that we can address an unlimited number of snapshots, and they're instantly available across all locations because it's a metadata-based zero overhead snapshot, right? Those clones are also instantly available, and you'll see that in a minute too. So this makes things like unlimited immutable copies available for ransomware detection, some other things, makes it very feasible, makes it very secure. The only other thing, I talked a lot about some of this, in provisioning, deduplication, erasure coding, but the one thing that also kind of sets us apart for other software-defined solutions out there is one of the points here is a non-disruptive upgrade. So this not only counts for software, a non-disruptive upgrade of software, which most people would expect. That's a pretty normal thing. But we also support non-disruptive hardware upgrades. So as a year down the road, you want to buy a new node. 3 years down the road, you want to refresh your hardware. This is a simple process of ejecting nodes, regenerating them, and standing them back online. It's non-disruptive for not only software upgrades, but you can forklift upgrade an entire cluster hot while it's running. What does this boil down to is that it makes it a lot faster to do all these tasks. When I'm talking about provisioning and I'm doing all this stuff and we're asking that algorithm to offload a lot of that management overhead, it makes it that much faster and it reduces that much time, right? The reduction of all those different protocols and different purpose-built storage makes it much more efficient. And year over year, the policies about being able to pay as you grow, add a node at a time, just in storage management. I have been with Commvault for almost 16 years now, 16 years next month. And prior to this, I actually, I came from Seagate. I've been in storage, building frames and doing this for well over 2 decades. And the one thing that we've always seen year over year is that storage is always cheaper next year, right? And so right out of the gate, adopting a philosophy where you can expand and scale out as you need it year over year is a 50 to 60% reduction in that storage cost. So it's very powerful in essence of the procedure that we can follow. So that being said, let me talk a little bit about a scale-out use case that we have with Hedvig. This is an aerospace company. There's a global entity. And what they've done, they are well over 9 petabytes into scale-out now, with well over 100 nodes. One of the driving factors here was to ensure locality, as they have different contracts with different aerospace entities, different space entities, different military entities, and that information had to be local specific to follow the rules of different countries as that information went on. So maintaining resiliency, but also ensuring that's exactly where I want it to be when I write a piece of data, right? And so the other components that really factored into this equation was the fact that we were able to not only all of the interesting things that I'm going to show you from a nice HTML, easy to manage interface, but it's also available programmatically, right? So our API is very powerful. It's in complete parity with what you see on the screen is what you have access to through either CLI or REST interface. So this makes it very powerful for a provisioning system, a automated service management system, to be able to go in and push that out to their end users and say they want internal customer user wants to provision a piece of storage to a server architecture, and they want a checkbox and they want that to happen. So this has been a storage as a utility has been so prevalent across all of our cloud providers, right? Google, AWS, Azure, all have the ability to just simply log onto a web page and say, I want 4 terabytes of storage on my server, click a button and it's there, right? And so this is Hedvig's ability to provide that utility storage philosophy, that utility storage feel on-prem with their existing storage, right? With their storage frames. And so the other driving factor is this, is they had a very diverse end user environment. They wanted to be able to programmatically allocate and provision storage out to physical servers, VDI, Kubernetes, and Hyper-V all simultaneously, right? And so this is one of the things that when dealing with an environment like that, it's a very diverse protocol set that you have to have, but they wanted a unified presentation layer to be able to allocate storage and provide it to those platforms consistently across all of their development efforts and all of their automation through Ansible Tower. And in this example, they're using a gold cluster, which is an all-flash system for high performance capabilities for applications that might require that, provisioning that automatically. A silver cluster that's more of a hybrid, so it's going to be a mix of solid states and spinning disks. And they actually have just this summer they've added a bronze cluster, I believe, and this is for the high density object store. Backup applications. It's going to be using those 336 terabyte nodes and that kind of nice, big, dense, great, cost-efficient storage, and that'll be available in their mix too. So I do want to jump through very quickly. So that kind of explains how Hedvig works, what's out there on the in the componentry, why it's so interesting, why it was so compelling for Commvault to make that acquisition last year. And the alignment of kind of that storage philosophy. So starting late last year, November, December timeframe, right after the acquisition, we began effort to integrate and be the beneficiary of these Hedvig technologies into our core products. And so the development effort for HyperscaleX started late last year to bring all of this intelligence, all of this scale out into our appliance, right? So prior to this, the HyperscaleX was using Gluster. So if for those of you who might be familiar with the original version, which is a fine, it's a production clustered file system. It's widely in use, but it is not considered necessarily scale out. It certainly reaches diminishing returns as you get to a certain size. Hedvig basically solves all of those issues. It kind of gives the HyperscaleX, the appliance, all of the things that I talked about on the storage platform. Now the backup appliance platform is the beneficiary of those capabilities now too. That erasure coding makes it very space efficient, and that auto load balancing and being able to add a node and have that storage rebalance across multiple nodes up to as many nodes as you need is again kind of one of those things where it lends to resiliency and it lends to performance automatically without having to go back in and remanage those disks. It still starts with 3 nodes, which is, when we talk about 3 nodes, it'll be 1 appliance, but you can add individual nodes and you can mix them as you go. It scales out to at least 5 petabytes within a single pool, and you can have as many pools as you need, because this is Commvault, right? We love having storage pools, and we can use as much as we need to do. The scale out is part of the power, right? So the HyperscaleX systems are available now. They just came out this summer. The hyperscale reference architectures, which is basically a bring your own hardware version of the HyperscaleX, will be available by end of year. This is on definitely on the dock soon. And the 2 models out right now are the 2300 and the 4300. You can see that they scale all the way from 48 terabytes all the way up into 504. And with the drive count that you see here, there are questions later about that. This is one I usually get asked the most, is when we're talking about a drive count here, it's each appliance has a drive count of 12. This appliance has a drive count of 36. This appliance is 3 1U nodes altogether. So each appliance having 4 drives for a total of 12. This has 12 drives in each node. All 3 nodes are 1 appliance for a total of 36 drives. Okay. Now, let me jump forward to the next set here and see if we can start my system up in the background. All right. And please, somebody speak up if you can't see my screen. Otherwise, I'll assume that worked, and we'll start the show here. So this, what you're seeing right now is the cluster watch screen of the Hedvig cluster. So I just logged in. So starting from the top left and we'll work our way to the right. This is the cluster watch tab. It gives you a quick glimpse of what's going on in the system. I've got about 12% capacity used up. This is a 6 node. My usable and use space is all displayed out here, and how many proxies I'm using. Graphically displayed out to my right side of that is that I've got 3 data centers, DC 1, 2, and 3. Simulation, kind of what we saw before in that diagram. And in each data center, I've got an HSP. That is my Hedvig storage proxy. Now, all these 3 storage proxies actually are also Commvault backup media agents. I don't think we'll probably get through all the media agent stuff today, but just to kind of lay that out, these are dual purpose, and these act as my connectivity points out to my application set. The lighter icons that you see in each cluster are my actual storage nodes. So they kind of give me what's going on at a glance inside the node. And each one of these icons, you can basically double click and drill down and get additional heuristics and information about each and every component that you see on the screen. On the top right-hand side, you see my notification bell and my alerts. This is if I've got drive failures, node failures, what's just the general health of what's going on in the system. But we're also compatible with SNMP 2.0 and 3.0. So if you needed to link this into your existing monitoring management system, absolutely support it. The gear handles user management and some other aesthetic management as far as like color schemes and whatnot. It is a multi-tenant capable system, so you can define quotas to tenants, you can define roles to users, and then you can assign those users to tenants, right? So keeping everything kind of in a classical hierarchical storage or hierarchical user management model. It is also able to plug right into your existing Active Directory or LDAP infrastructure. So if you wanted to manage outside of this, of course that's supported. That is really it for the front side tab. The only other tab we have in the system is the virtual disk management tab. This is where it lists all of the disks available inside of Hedvig. I've got 2 of these defined. I'm going to go ahead and create another disk quick here. I'm going to call this my scale out demo disk. And I can define this of any size that I need to, of any type that I want. quickly and easily. It's thinly provisioned. So this is, again, the only thing this does take a capacity against is if you've defined a quota for the tenant. The disk type is going to be block NFS. Object store is also available. I don't have that in my lab right now, so that you can cover any protocol at the actual definition point. I'm going to build it out as an NFS volume. And when I do that, it's going to ask me what workload type I want to use. Virtualization, backup, OST. I'm going to define that as a backup. But what happens in the background is that we're going to be pulling levers and turning knobs that optimize the block type, the protocol, all the things that make sure that you're talking to that application the correct way without having to go in again and micromanage those assets. Encryption, deduplication, and compression are available on a volume by volume basis. I'm going to leave them off for now. Replication and erasure coding is also available, again, disk by disk, but I'm going to leave it as data center aware, because one of the things that I absolutely love is being able to define not only my resiliency, but my locality. This could just as easily be Los Angeles, Dallas, and New York as my data center locations. And just by clicking on where I want my data to reside, it's going to increase my replication factor to ensure that I have blocks available to read from, no matter where I am writing from. Our proxies will make sure that we're opportunistically writing correctly wherever they need to write to, and they can read from wherever those blocks are available in case of that failure, right? The last checkbox down here is hard drives or flash. And this is essentially, this is a pin to flash. They probably could just call it pin to flash with a checkbox. And that'll make sure that it goes out. And I talked about those storage nodes before. But when you define those storage nodes, it's just assimilating raw storage. It's just disks or solid states or NVMe, whatever storage you've allocated to those storage nodes. We see them just as JBOD, right? And so when you define flash, it'll actually go out and make sure that it's grabbing the best flash performant disks within the cluster that it needs to provide you with that performance, right? When I define that, it'll drop out here in my main screen. There's my scale out demo disk. He's ready to use. I could go plug him into a backup. I could go define him as a data store. I could start using the store, whatever I need him to do, he's ready to go. It's a simple matter of just exporting him out to my application at that point. Now, the other thing I wanted to go through quick is I've got my guy here, my snapshot victim. Is that this is the snapshots that I have running all the time. And again, defining a snapshot is literally as fast as you can click the button, it'll build snapshots for you. And the snapshots are, again, immutable metadata-based snapshots. So they are unlimited in capacity and instantaneously available across data center 1, 2, and 3, just like I had before, right? So I'm going to go ahead and I'm just going to pick one and tell it I want to clone that volume off. So creating a snapshot of it keeps a nice safe copy. But now I can go out and say I want to make a dev SQL spinoff copy. I'm going to spell SQL my own way. And I'm going to tell it that I want to build a batch, right? And so this, again, also available programmatically. Very simple, just to go through and say, I want to build a new clone, sure. But I can also go through and say, why don't I build 4 clones? Maybe I've got 4 developers that are all working on the same application at different times. So that'll be available there. And maybe they all sit in data center 3. It's a refresh volume. I don't really need to have all that resiliency into it. I'm just going to blow it away and build a new one next Friday, right? So as fast as you can define its location, define its locality, and hit the button, it'll build those volumes out, and they're ready to go, right? So from there, I think that is everything. So it is 2 tabs and 15 minutes to master Hedvig storage. It is a very simple system. It is very straightforward and incredibly powerful in simplicity. The only other thing that I will show for anybody who is in from the existing Commvault side or might have seen this before, I will bring up a quick, because this takes literally seconds to look at quick. This is a Commvault command center. For those of you who are Commvault customers, you've seen this, you probably use this every day, but this is the same process that we go through when you're defining storage, when you're defining cloud, when you're defining tape. These are all things where you can go through and you can mount those up, you can attach those volumes, you can manage that disk capacity. But with Hyperscale, It's all done for you. So everything I showed you on the back end was how you can use our storage platform. But as a hyperscale uses it, this is all built in. There is no management layer required on the back end. All those nodes can be added automatically into into your comm cell, and that storage is provisioned as it's needed, right? So no management, no definition of volumes, no having to export them out to another application. As Hedvig is used with hyperscale, it's automatically provisioned for your backup applications and used as you need it. With that, I think we can open it up for questions, right?
Yeah, absolutely. Wow, you gave us the right time for questions. I didn't even need to give you a marker. I do have some questions here, but does anybody want to unmute themselves and ask a direct question to Chris? I can leave a couple minutes for that, or else I can go here. You can just unmute yourselves. Okay, so one of the questions that I have here, let me just take a look at it. And I'm not sure if you answered it already, and please forgive me if you did, but it says, can Hedvig clusters be expanded with different brands or disk types, or do they all have to be the same? And is this also true for HyperscaleX?
So absolutely. So this is one of the really this is one of the abilities within Hedvig that sets us apart really from all other solutions, and it's the ability to expand at dissimilar geometries, right? So a Hedvig cluster can have, for example, you buy 3 nodes this year from your vendor of choice, whichever storage, whichever server vendor that you like to buy from. And then next year they've gone out of business, or your company has negotiated a new contract with a different vendor and you have to buy different servers and all of that good stuff that happens year to year. Well, if the power is buying it at over year to save money, but you can't do it anymore, it kind of defeats the purpose, right? And so Hedvig supports dissimilar geometries. When you go out and you can mix and match drive types as you expand a Hedvig node. You can mix and match brand types, different servers completely. They don't have to look at all the same way. And even where we have customers that have storage clusters that have, I talked about those in the use case, gold clusters and silver clusters, and these are flash and these are hybrids. That absolutely, but that is an approach that they took programmatically because that was their preference. Those geometries between those node types can actually be mixed and matched within one cohesive cluster, so that when you want to use flash, it will automatically use the flash nodes, and when you need hybrid, it'll pick up the hybrid, and that way you can use primary and secondary, tertiary object all together, and it'll intelligently use the right tier of nodes and storage that it needs. The other part of this is, I guess the follow-on to that is, does Hedvig or does Hyperscale use that same philosophy? It does to a certain extent, yes. If you're using the reference architecture, again, that's releasing out in the next few months, that would be much more appropriate for that. But if you're just using our appliance, where you buy the appliance from Commvault, it's the 2300 and the 4300, they actually came in multiple flavors. I think everybody saw that on the screen. There's the 48 all the way up to the 504, and those nodes can be mixed and matched. So the 2300s have 3 different drive type flavors. The 4300s have 2 different drive type flavors. And so if you want to expand one node at a time, they can be higher density, they can be lower density. Now, most of the time, you'd want to balance them out. It doesn't always make more sense to say, I want to go really big on one and then add like just 48s to a 504. Might be a little lopsided, but it is supported because Hedvig inherently has that capability built into it.
Awesome. And Adiz, I think this question is actually meant for you. How is HyperscaleX and Hedvig priced?
So, I mean, from a pricing perspective, on the HyperscaleX, it's very straightforward. The capacities Chris shared there are reflecting the usable capacity per block purchase. I mean, those are 3 node blocks basically, which can be expanded a single node at a time. So the pricing there is based on the usable capacity. So straightforward. And on the Hedvig, we have basically 3 tiers of pricing: an object tier, a backup and archive tier, and a primary tier. So perpetual or subscription. We are still pricing their raw capacity. The simple reason is we're not able to conclude with a usable capacity, because a customer may do replication factor of 2, and they may have for another workload replication factor of 3, 4, depending on the protection level they expect. So for that reason, we are pricing the raw capacity for traditional storage. And the goal is in the next couple of months to simplify it further, looking at several options. So.
Okay. Anyone on the call have a question for these two gentlemen, Adiz or Chris?
I do have a question. Currently, we're a Commvault customer. We have Hyperscale appliance in 2 different sites, one in New Jersey and one in New York. So we're already using the Hyperscale that we purchased, probably 18 months to 2 years ago, probably 18 months ago. We're now expanding to AWS Cloud. So first of all, how can I justify buying more appliances when we already just purchased appliances? What does Hedvig give me that I don't already have? And what does it do for me for ongoing cloud? I mean, it looks to me like it's more just of a consolidation type of a service that consolidates storage. But how can I go to management and say I need to spend some more money? That's kind of where I'm at.
Yeah, so with the HyperscaleX or Hyperscale, you're already leveraging, Randy. I mean, that movement happens, of course, if you need additional capacity. So the beauty of how things are done today, the Commvault, the interface part without the appliance, that allows you to be able to phase the data out to public cloud in a seamless fashion. So in fact, we are the only player who can go to cloud without a gateway and give you deeper archival capabilities, or maybe even expansion capabilities of the capacity. And of course, the key consideration there, the latencies, and if you can really restore fast enough from the cloud based on the user expectations, your audience out there. If I look at Hedvig, what it can do in your domain, we can definitely bring that consolidation and seamless step into the cloud, because just like a compute instance in the data center, an x86 server, which you can install Hedvig on, you can also have an Amazon EC2 instance, and the core idea becomes now you have a single presentation layer with an infrastructure that may be spanning your data center and clouds, and you can have data replicate, again, across both of these domains as you like, the way you want to protect the data. And one day, if you want to maybe establish more of an architecture, let's say only an Amazon across several zones, availability zones, you can even establish that. So we would enable the replication, we would enable basically seamless shutdown of the data center over time, taking all the burden and headache. This is all on the storage infrastructure part, of course.
Chris,
does that make sense?
Do you have anything to add to that?
Certainly. So yeah, a few of the defining points on there is that it's certainly, I mean, hyperscale is hyperscale. I definitely want you to take that away from the presentation. Is that the new HyperscaleX still provides that same seamless interface back to the command center. So that's not a disruption in that at all. But I agree with Adiz. It would be more along the lines of if a capacity expansion was going in place. They are built to stand side by side. You can migrate between them, and it would be something where that if you wanted to, for a capacity upgrade at your primary and move your existing appliances to remote locations, that would be a use case. But if it wasn't going along that line, I probably wouldn't go. I wouldn't do that unless you absolutely needed more capacity. It's certainly not something where I would recommend somebody who's happy with a hyperscale today just to go just to go rip it out and put it into HyperscaleX. We'll be here in a few years. If you get down to that point and you're ready to do a refresh and ready to do an upgrade, it would definitely be the next model that you'd want to go to. Beyond that, for cloud connectivity, both Hyperscale and HyperscaleX both support plugging directly out to AWS or Azure or any cloud provider natively without using a gateway. So if you haven't explored those options, by all means, get a hold of your account team, and we can run through any of that with you.
All right, thank you.
Great. Anyone else in our last 3 minutes that we have together have a question for these two gentlemen? Okay, so I'm gonna then give you guys 3 minutes back of your time. But I wanna thank you all for your time, and I hope you had a great lunch on us. This is recorded, and so I will send it out to you as well as some other folks who aren't able to join today. But I wanna thank you again for your time. Adiz, Chris, you guys always rock. You guys are my favorite. And thank you, gentlemen, for being on the call with me today, and I look forward to talking with all of y'all again probably in the next week or so. Thanks, Franz from Hawaii.
Thanks,
right.
everyone. Thanks, Naomi.
Take care, gentlemen. Bye.
Have a great day.